All right. Once again, we are going to talk about destructuring. And please, in the chat, let me know if the connection continues to be bad. Let's see if I can figure out something else. Destructuring, creating variables from objects and arrays, creating objects with same variable name key value pairs. We'll talk about spread operator and how we use it. There's like a principle of immutability. I don't know if this is exactly what we call it, immutability principle. We basically never want to, if we ever alter something that is an object or an array, we never want to change it directly. We would rather, it's better to make a copy of it. We'll talk about arrow functions again. We'll just do a quick review of how they're written, and then we'll kind of try to see them in different contexts. Nothing that you haven't seen before. Is it gone again? Can you guys still hear? Darn it. Still?
It's fine. Yeah.
Okay, cool. The green box around my screen went away, which happened last time. Okay. And then the big kind of lesson for today is going to be class syntax. So we'll talk about transitioning from object-oriented programming back into object-oriented programming from functional, which is something I didn't really signal at the beginning, which I wish that I had. We'll talk about defining, well, I guess it'll kind of be more like defining instance methods. We'll kind of talk about the limits of class syntax in JavaScript, or things that haven't quite been figured out yet. We'll create some instances, and then the big thing that we'll really want to talk about today is this keyword and arrow functions. Okay, so let's get started. This is just kind of be workshop style. I'm just going to kind of give quick examples of each of these things, and then if you have questions, of course, you can ask. So let's start with destructuring. Destructuring is a fun way to pull values from arrays and objects and create variables out of them. So let's start with objects. No, let's start with arrays. So let's say I have a teacher array, and I have inside of it Chris and Cernan. Let's do these three for now. And I have these values in an array, and I know which order they're in, and I need to use them as variables. Instead of saying let Chris equal teacher array 0 and let Jen be teacher array 1 and let Cernan be teacher array 2, right? Maybe trying to iterate over them or something like that. I can actually just use destructuring and say let Chris, Jen, and Cernan equal teacher array. I know this is extremely confusing syntax because we're saying let, and then we're creating an array, and then we're saying make it equal to an array. That's how it's written. If I come over here and I refresh this page, so remember this JS file is connected to this index.html file that I have loaded up in the DOM. So everything that I have written in here is already here. Chris, Jen, Cernan are all variables. The syntax just takes practice to remember. Look it up, but it is very handy, very useful. So this is destructuring with arrays. And then we'll do with objects. So let's say I have a, let's say that I have a student object, and I have the student's name, it's Chris, the grade is 12, and the can graduate is true. Let's see, toggle soft wrap, cool. If I want to take this student object and take the keys and put the values into variables, I can do the same thing. I can say let name, grade, and can graduate. I set it equal to the student object. So now name, grade, and graduate are all now variables. It's important that the variables are the same name as the keys. If I change this to a name, a grade, a can graduate, it's not going to register. In order for destructuring to work, the variables that we create for an object need to be the same as the keys. Again, just tricky syntax that you have to practice to use, to memorize. But that's kind of, it's basically it.
And Chris, if I may, can you explain why destructuring and why this is so important, or why you would use this?
Well, let's, yeah, the next step was going to use it in an example, right? So let's say that this is something that we're going to be using a lot in React, and it's not saying that you couldn't do it the other way, because of course with the student object, I can say student object.name, and that gives me the name of the student object. I can say student object. When I use destructuring, I kind of save myself a small step, right? That's really it. I don't know, the saying goes that coders are lazy and that they're always working hard to try to find ways to make things easier. It just, can save you time, and it's becoming more popular. Not saying that everyone at a job that you'll go to will be using this ES6 destructuring syntax, but it's definitely bonus points if you can demonstrate in your coding interview that you understand destructuring. It's just the newest updates in JavaScript, kind of keeping up with the times, essentially. So let's look at an example of when we might use this. So, for example, let's say so far you have all maybe written a function called add student to, or render student, or student HTML, right? That maybe received a student object, and then you hoped to maybe do document.innerHTML of something, right? And gone ahead, as an example that I have done in the past, right? And said something like div like this, and then said something like student name equals, student object.name, student object, student grade, and graduate. Something like this, right? We kind of should have at some point have all done something like this by now. With destructuring, you can actually, if you receive the object as an argument, you can destructure right in the argument here itself. I can say name, grade, can graduate, which is the exact same thing as here, right? So this is keeping kind of one step further in destructuring. The newest versions of JavaScript understand that if you receive something as an argument, as an object, as an argument, and you can predict the keys that are going to be passed in, you can go ahead and write them here. You can destructure them here, and then inside of your function, you can just use the variables as you've destructured them. There's nothing wrong with you doing it the other way. This is just kind of the new flashy, the new flashy way to do it. The same thing goes with the teacher arrays. Right. Notice, however, that as a difference that I wanted to point out would be that the variables for the teacher array, if we want to destructure them, don't have to match the names, obviously, right? if I did this, and I said student HTML, and I passed in my teacher array, so it should be teachers. Does it show up? Does it work? And I need to document.body.innerHTML. Let's see. Yeah, there we go. Again, with arrays, the variables that we destructure don't need to be the same as the names themselves. Oh, parameter name duplicate not allowed in this context. What did I do? What did I do? What did I do? Oh, 2, 3. So again, destructuring with arrays. The variables that we assign the values in the arrays to do not need to match the values themselves, obviously. With objects, however, they do. Notice that when I'm destructuring an array, I say let, and then I put the variables inside of brackets. And then when I'm destructuring an object, I put them inside of brackets. Sorry, curly braces, brackets, curly braces, brackets. Okay, the other fun thing that we can do with objects is if we have a variable that holds the value and we want to put that value inside of a key, or sorry, inside of an object with the same key as the variable name itself, we can do that. So imagine you're making your config object, right, for your fetch requests. You're making a post requests, right, a post request config object. And you have your method and its post, and you have your headers, and then you have your body, and then you're stringifying it, right? You're passing an object. So let's say that you're creating a new instance of a user, and you have a name variable that you've selected from an input field, and then you have a password that you're selecting from an input field, and you want to pass this object, you want to pass these values into your config object body that you're going to ultimately send as parameters to your backend, right? So instead of saying name is equal to the name variable and the password is equal to the password variable, if the key in your object matches the name of the variable that holds the value that you want to place here, you can now simply just put the variable name. You'll see this very often in React. Again, if the key for the object matches the variable that holds the value that you want to put as the value of the key, you just need to write the variable name. This will automatically create this for you, right? Well, it would essentially be this, but then the variable name equates to whatever string we've written in, right? So all you have to do is put this here. And I guess to kind of show you an example, I'll save this, refresh this page. Name has already been taken. Where did I put name? Somewhere else. Name. So if I go look at this config object, notice how it put in the name and the password for me, but all I did was put in the variable names because the name of the variable matched the name of the key that I wanted it to go into the object as. Okay, any questions about that? Really simple, small tricks, just save us a little bit of time, cleaner and easier to read. At the end of the day, you can still do it the old-fashioned way if you want. We encourage you to try to use ES6 where you feel comfortable doing it. It's definitely something that might come up in your project review. How do we destructure this? Do you know what destructuring is? Or if you did use destructuring, can you explain how you did it? Can you explain to do it in these other contexts? So practice it. I don't think that it's like a pass or fail. You know, it doesn't have that. It doesn't have that scale. But you know, make sure you're practicing it. Any questions so far? Okay, let's talk about the spread operator. So as I hinted at earlier, moving forward, we're going to kind of, especially in React, follow a principle of immutability. And it's not that these things are immutable. It's that we want to practice maintaining what would be the best way to put it? When we're using objects and arrays, which if you remember before, I said are passed by reference and not by value, meaning that objects and arrays share the same space and memory when we assign them to different variables. So if I have this student object and I say let new student object equal this original student object that I have up here, and if I make changes to that new student object, if I add new key value pairs to it, it's also going to change the original student object, right? And for this reason alone, sometimes we can't always keep track of where we have referenced other objects, and sometimes we don't want objects to change where we've referenced them in other places, right? Key takeaway here is that for arrays and objects, whenever you are making changes to them, you should always make copies of them. And I guess I'll write that here. Moving forward, all changes to arrays and objects should yield copies. So if I truly wanted to make a copy of the student object without holding the reference to it in memory, I would use the spread operator. Spread operator is super simple. I'm preparing to make a new object. I use 3 dots and then reference the variable that holds the old key value pairs for the other object, right? So in this way, I have completely made a new copy of the student object. The key value pairs are copied in. If I want to add something new, you know, honors, false, right? In my new student object, I've created a copy of the original student object, but the original student object goes unchanged. Okay. All right, we can do the same thing with arrays. So if we have this teacher array up here, teacher array, I want to say let new teacher array equals teacher array. And then we'll say, Ashley, we want to put a new teacher here. Oops, what did I do? Oops, I want to go like this. Arrays are brackets. New teacher array. There we go. Spread operator. This is going to be most important when we learn about something called state. It's essentially going to be a place where we're going to hold information that our application needs, and we'll often make changes to what's in state. For example, if we have, as you've seen already, maybe we have some toys, right, on our application, and we want to keep those toys in state, meaning we want to keep track of how many toys are on the screen. We might add a new toy, and we will continue. We might define state up top as an empty array or as an empty object, and then, or you know, we might have some predetermined, you know, user logged in user null. How many toys are on the DOM, right? Let's see, like, we can just do those two for now, right? And then so maybe a user has logged in, right? So we'll say let state equal, and we'll want to spread state, but we'll want to change logged in user to this new value, right? And then maybe we get some toys in. So we'll say let state equals spread state, and we'll add the toys. Woody, Buzz, etc. So what happens here, as you'll see, oops, sorry, I don't want to let state. I just want to change the state. We're resetting the value of state using let, right? This is not defined. Where did Chris go? Oh, just put it as a string. If you're using the spread operator and you spread the original object, but then you write a key that already exists in the state in the previous object that you spread, you will overwrite it, right? So notice that I'm changing state here twice. The first time I'm changing state, I am here. I'll actually just kind of also log it so you can see how it changes. So the first time I changed state, I set the user, logged the user to Chris, but the toys was still an empty array because I spread the state previously. So the toys never changed. The second time I just changed the toys array, but I had spread previously, so the logged in user was preserved, right? So now I have a completely updated state, and each time, remember, I'm making a new copy. Okay, so we want to follow this principle. Any questions about the spread operator? Why we want to always make copies of our objects and our arrays moving forward? Spread is basically splat in Ruby, right? I think so. Yeah. Yeah, some of you may have used not only the spread operator, but destructuring in Ruby. It was something that was available then. It wasn't very popular. We didn't really, push people to use it very often. There's a similar technique in Ruby as well. So a lot of these concepts may be familiar to you already. Okay, let's move on to arrow functions. These should not be unfamiliar to you, but as I've mentioned before, we probably want you to use, I had been encouraging you to use regular functions in lieu of arrow functions previously, because I wanted you to just feel really comfortable using regular functions. Arrow functions, again, are always inherently anonymous, because if we want to save them to a variable, we have to define a variable to put them in. So, add to holds an arrow function that receives a number as an argument. So again, arrow functions are generally always written like this, but they're inherently anonymous. So I'm not saving this to anything. I'm defining a function and then it's being stored in memory and never accessible again, right? Again, the same way to write this function using the normal function syntax would be just like this. So what I tell students is all you're doing is taking out these equal signs and this arrow and changing the const to a function. That's it. We're no longer setting it to a variable because the function keyword makes this name a variable for us if there is one, right? And then we just put that arrow in there. You should feel comfortable going back and forth. Remember also that if you write the function on one line, you do not need curly braces and you do not need return. The returns are implied. The other kind of confusing thing is if you only have one argument, you don't even need parentheses. The most common place you may have seen these so far is in fetch when we're using .then. And I've always told you, if you've worked with me, I've kind of made you do this, I make you write it the hard way, but you may have seen people, or you may have seen it in your labs, written like this. Because it is faster and looks nicer. But if you can't write it this way, you need to practice writing it this way as well. You can't forget, you have to be able to write both. Because if you write it like this, but you don't know how to write it the other way, then that signals to cohort leads or people doing your project reviews that you're pattern matching. You're just looking at code and following how you think it's written, but you don't understand that this is a function. And you wouldn't know how to manipulate it any further than this, right? But it's important for you to practice writing it this way so that you can say, okay, cool. So, let's make it look more like a regular function. This is still an arrow function, and this still works, right? We take it one step further. Now it's just a regular function. What's the benefit of saving an anonymous function to a const? Well, the only way that you can access a function for an arrow function specifically, if you want to reuse it later, right? Which we'll be doing all the time. So you could write this as an arrow function. You can say res to JSON, and you can just write res.json. And then in your fetch, you can just pass in the reference to that function like this. Because I saved it to a const, I can reuse it later, right? And this might not be a bad idea, because how many times do you use a fetch request and how many times do you redefine a function inside of this .then? Why don't you just write it one time and reference it over and over again, right? Something you can do or think about. Not that it really saves that much in terms of memory. It's really not that much more efficient. Our browsers are pretty fast now. We're writing something that small doesn't really do anything, but you could think about it as saying, well, I just write this function once and call it over and over again. The big takeaway with arrow functions and why, it's important to remember, and this is the next thing that we'll talk about once we get into class syntax. There are times where you must use an arrow function and times where you must use it. They are not always interchangeable. We've seen them used interchangeably so far, but there are times where you do not want to use an arrow function, and there are times where you do not want to use a regular function. And we'll go over that next. Any questions about arrow function syntax? Okay. JavaScript class syntax. So going back to what I was trying to say earlier, transitioning back into object-oriented programming from functional. You may have realized that besides from your CLI projects, which had kind of run files where you just wrote a bunch of methods, once we moved outside of that, we were almost exclusively working with files that had classes in config files, right? Our migrations were classes, our controllers were classes, our models were classes, our helpers were classes. We were strictly working what's called object-oriented programming, where we were making instances of things, right? Or referencing their classes and calling methods on them. In JavaScript so far, you have strictly been writing functions and understanding that functions are first-class citizens in JavaScript, meaning that supreme functionality. They can talk, you can pass them to each other, you can store them into objects. There are fewer rules, essentially. That's kind of how it feels, that JavaScript is like the wild, wild west, right? Well, people have, tried to say, okay, well, and if I haven't made that clear yet, JavaScript that we've worked so far is primarily functional programming, right? Where the mentality of thinking about constructing an application is through the focus, the aperture of writing functions and having functions perform the work. Whereas in Rails and Ruby, it was creating classes and creating instances and having those dynamically interact with each other, right? So of course there's always interaction going on, but are you thinking about first making an instance or making a class out of something, or are you thinking simply about writing a function? Again, so far in JavaScript, we've just been worried about writing functions. In Ruby, we were always concerned with making instances and classes. right? So again, people have been trying to force this kind of syntax or this the creating the feeling in JavaScript that you are writing an object-oriented style of programming. At the end of the day, it all compiles back down into functions. It's kind of the important takeaway here. But we can write JavaScript like we were writing Ruby, and it does have a lot of the similar functionalities. There are some things that aren't quite worked out yet. For example, people debate about what the best way to create a class variable is in JavaScript. They're still trying to develop one. As a preface, we will teach you this object-oriented class syntax will be essential to the way that we teach you React. However, with the most recent updates in React, JavaScript seems to kind of be, or at least React is moving a little bit away from this philosophy of using class syntax. So class syntax is quite new. It's not quite sussed out yet, and it's also kind of changing, or maybe as far as the world of React goes, becoming less essential. So keep that in mind, but I'm going to teach you the basics of what you need to know to use React. React is going to feel a lot like Rails in that everything will kind of, well, not everything, most things will be classes, but not all. And it'll be important to know when to use classes and when to not use classes. But again, there will be kind of a pattern that you follow that'll kind of get you to where you need to go. But it's important to remember at the end of the day that it all kind of boils down to this. So let's dive into class syntax. To define a class, you just write class this, right? And then instead of having an end, we just open up our curly braces. We have, just like initialize, we have a constructor, and the constructor takes in the variables, or the arguments that we're going to use to create this instance of a pet. So we have a name and an age, maybe we'll do. In JavaScript, why am I think this is right. I think this is right. Okay. In JavaScript, there's this special keyword called this, and this behaves mostly like self, but not 100%. It has some strange behavior, but in the environment of class syntax, we can use it like we were using self, or sorry, not self. Well, a little bit like self, but in the case of creating an instance of something, we use it in lieu of instance variables. So this dot name equals name, this dot age equals age, instead of saying at name equals name, at age equals age, right? Oops, I have to do this. There we go. That's what I was looking for, the blue. All right. The constructor creates the setter and the getter methods for you. If you want to write setter or getter methods for things that aren't in the constructor, you can say like set owner, and then you can pass in an owner, and then say this dot owner equals owner. You can say get owner, this return this dot owner, right? This behavior works. I'll just count this up as essential to what I want right now. So over here, I don't actually want to make a fetch request. I don't know what's up with my internet today. I think I maybe didn't pay my internet bill, which I should probably do. Okay, let's get rid of these as well. So then over here, if I want to make a new pet, I just say new pet. I guess I should save it. So let's say let spot equal new pet spot, and spot is 2 years old. Okay. Spot is a pet. Look how it just boils down to an object. Same, I mean, I guess, JavaScript or Ruby instances, had that specific kind of, look like they were kind of within arrows. But in JavaScript, it just boils down to an object. We can, of course, write instance methods for these objects. We can say name, and there's this, we can console log, hi, my name is, and then say plus this dot name, right? So Spot, although we can't see Spot's functions, I can call name on Spot. Hi, my name is Spot. Okay, now let's talk about inheritance. Works very similarly to Ruby, Rails. We say class dog extends pet. A dog is just a pet, right? So in our constructor, we still need a name and we still need an age, but then we also want a breed and maybe a favorite toy. If we have a class that inherits from another class, we use the word super, and we pass in the variables from the constructor that will then, it'll basically run the constructor of the thing that it inherits from. So pet already has a constructor for name and age, so we could just pass those things into super. And then this dot breed can be that, and this dot fave toy can be that. Okay. So if I do this again, and this time I say new dog is Spot, and Spot is 2 years old and is a lab and loves the peanut butter ball. Spot has all of these things. I can also still call name on Spot. Okay. So again, missing some of the features that we're used to. I'm going to look this up a little bit more for tomorrow, but I believe we can use the keyword static to use. Like we can say static can be a class method, and the kind of hacky way to make class variables is just by calling the class and then putting a variable on it. So class variable, you know, pet, you know, all pets, something like this. There isn't a secure way, there isn't like a 100% agreed upon way to create class variables in JavaScript using ES6 syntax. We'll talk more about relationships tomorrow. If we have, well, maybe a little bit if we have time today, but that's mostly going to be what it's about tomorrow. We're basically going to talk about applying class syntax to DOM elements. But the next thing that I really want to show you all is we're going to take a quick look again at the powerful, you know, the power of the arrow function. So Nelson, I believe that we may be able to do this. We can say class pet, and then I think we can say this dot constructor dot all pets equals an empty array. I think we can do this. On line 83. Constructor. I'd have to look into it a little bit more. Constructor dot all pets. No. I don't remember off the top of my head how. Maybe we could do this dot constructor dot all pets dot push. Oh, that needs to be. Yeah, I'll have to look it up again. I think there is a way to do it inside, but I don't remember. I don't remember off the top of my head. I'll look into it. We'll definitely touch on it tomorrow. What did I do? Line 83. What did I do? Classes may not have a field name called constructor. What do you mean? Maybe I just didn't save it. I thought I saved it. There we go. Okay. So Let's imagine that we wanted our dogs to have the capability of having a puppy. And I know most dogs don't have one puppy at a time, but bear with me. So let's create an instance method called havePuppy for a dog, where we take in, and notice here that whenever I'm inside of a class and I'm defining a function, I don't need to write the word function in front of it. If it were an arrow function, I also wouldn't have to do it, but we'll look at that in a second. So havePuppy, okay? HavePuppy is a function. And basically what I'm going to do is I'm going to say let puppy equal, oh, and I also probably want to pass in the name of the puppy, what we're going to name it. Let puppy equal new dog. And then of course we'll pass in the name that we've received as an argument. The age will first be 0. The breed of the puppy will be the same as its parent. So can anyone take a guess on what I would put here to reference the breed of the parent? How would I access the breed of the parent from within here? Not quite. Super is what we use only inside of the constructor. Andrew's right. We would say this.breed, because the this keyword is going to be referencing this instance of the dog, right? And then maybe the dog doesn't know its favorite toy yet, so it'll just be null. We don't have an attribute for a dog in this moment who their parent is, and that's because I want to show you this JavaScript feature. So we can remember that these elements are just, or these instances are really just objects, and we can add keys to them with values. So I want this puppy to have a function called whoisMom, and this function whoisMom is going to just console log my mom is, and then I just want to put the name of the mom here. So earlier we said this.breed for the name of them, for the mom's or for the parent's breed. How should I get the name? Name, right? And then after I'm done with the puppy, creating the puppy, I want to return the puppy so that I can save it to an instance. Okay? So again, I've created an instance method for a dog called havePuppy that accepts the name as an argument. Inside of it, it creates a new dog and passes in the name that we received as an argument. The age is this 0. This.breed is supposed to reference the parent's breed. Null in favorite toy yet. Then I've added this function to the created puppy object called whoisMom. If I invoke this function, I expect to receive in the console a log that says my mom is, and then the name of the mom. Okay, so let's try this out. I have Spot, right? I want Spot to have a puppy, and I'll have the puppy's name be Max. So I'll say Spot.havePuppy, and then pass in the name Max. Now Max is a puppy that I've created. And you have the name, the age, the breed, the favorite toy, and then this function whoisMom. If I call whoisMom on Max, it actually says my mom is Max. That's not right. That's the name of the puppy. The mom's name is Spot, right? Can anyone does anyone know why this happened? I want to take a guess.
Whatever this is what you call the function on, and you call the function whoisMom on puppy.
Exactly.
So this is the puppy.
Right. So Lucy just explained one of the strange behaviors of the this keyword. Generally, when we're working with instances or the class syntax, the this keyword is supposed to reference the instance that we're in, right? But the this keyword has behaviors that outside of class syntax that also affect how it operates within class syntax. Lucy pointed out that whenever you call a function on an object, that object becomes the this keyword. So notice here that I called whoisMom on Max. And when I called whoisMom on Max, this function ran. And when this function ran and it wanted to decide who this was, it inherited this keyword, or the execution context as what we would call it, of the object. So the takeaway here is that the normal function, the regular way to write functions, the function, whenever we write normal functions and we have a this keyword inside of them, the this keyword is determined when the function is executed. Okay? If I want the this keyword inside of here to always be bound to the context in which it was defined, I have to use an arrow function. This arrow function will define this function and say, okay, this keyword where it was defined is inside this instance of a puppy, which is spot, right? So now this dot name is going to refer to spot and not max. Basically what I'm trying to say is that if normal functions determine their this keyword when they're executed, we use an arrow function to preserve the this context to where it was defined. The this keyword where this function was defined is inside the instance of spot. So if I refresh this page and I do all of this syntax again, so this is the key feature of arrow functions that you should know. If you want to bind or lock in this keyword into the instance where the function is being defined, you should use an arrow function. This is a very common problem or a very common thing that you'll need to know for React. Again, there may be times which you do want the function to inherit the context at the moment it's defined, right? So let's say we have a bunch of objects and let's say we have a bunch of objects and let's see. Let's say we have a bunch of objects. So let's say we have some students. Student 1, name Chris, grade 12. And then I have another student, Lucy, in grade 11. And then let's see, can I do this off the top of my head? And then if I have a function called sayName, and I just say this dot sayName or this or console.log this dot name, right? What I can do here is I can say let Chris sayName equal sayName dot bind to student 1, and then I can call this function here. I can say my name is, okay, so look how I defined a function with this keyword, right? I could have, I can't call sayName on one of these objects because that's not how I constructed it to be. But what I can do is I can take that function sayName and I can use the bind keyword, which there's a lesson about, bind, call, and apply, but the most common one that you'll probably experience is bind. And when you bind, you're saying, hey, inside of this function, if there's a keyword like this, make it reference this object that I'm passing as an argument, right? So I've basically taken this function, created a copy of it, right? Saved it to this variable where this keyword inside is locked into this here, right? Here's an example of where we would want, well, I guess, I don't know if this is really maybe this could also work with an arrow function. Let's see. I wonder if it does or it doesn't. Let's check it out. No, okay, cool. So I try to use an arrow function here. And again, an arrow function defines this value when it's defined, and it ignores this bind here because it's already been bound. And because this keyword, when it's defined, when this function is defined, it's the window. It's just the page. There is no this context. This dot name is just nothing, right? So you'd see here how there are cases in which you want functions that that can be influenced in a way where this keyword can change, right? The takeaway is that if you ever want to use a function and call it on another object, in this case, we defined this whoisMom function, right? And we're ultimately going to call it on the dog's puppy, but we want this keyword to always refer to the mother, right? The original dog. We want to use this binder function in this way. As Nethelbert also pointed out, we could maybe have we could use the bind keyword here, and there are going to be more examples of this that we'll talk about tomorrow. But this was just meant to be a basic introduction to all this ES6 class syntax. This is not going away, so if you don't get this now, don't worry. There's a lot of it coming up ahead. All right. Are there any questions in the last few minutes before we go?
Yeah, quick question. So of course we're using the arrow key, right? Which is pretty cool because the arrow key definitely stays or keeps the context of this. Now, can you also, let's say we use an anonymous function, right? And we probably passed in a, what is it called? There's like a second option inside of anonymous function that you can actually use. So you can have like your variables, and then you can do another option. I forget the other option that it's called, but I remember I did it in one of the labs, and basically that other option was able to actually create the context for the word this, if I'm not mistaken, as well.
I don't remember that off the top of my head. Like you can pass in an argument here that determines the this context.
Yeah, I'm trying to remember exactly how they did it again. Maybe it was actually, no, you know what? It was actually for a callback function, I think it was. So basically, the anonymous function was utilized, but inside the anonymous function, it also had a callback function, and then it was able to determine what this was.
Was it an anonymous arrow function or an anonymous? I'd have to look at it.
Anonymous, just an anonymous function, not an arrow. No.
Can you send me it? Send me the example, because I would imagine is that they would. Yeah, send it to me because I want to see.
Sure, absolutely.
A lot of the JavaScript curriculum is new, and I haven't gotten to look over all of it yet. So maybe it's a lesson that I haven't seen yet. But yeah, send it to me and we'll talk about it.
Okay, cool.
All right, everybody. Sorry, is there another question?
Oh yeah. I also actually have a quick question about for each, because there was an example in the labs where they called for each on an array. And this in for each referred to like the global object. And I just don't really understand why that is, because wouldn't this be the array, because you're calling the for each on the array? So why is it
seems like you are, but you're not. Because you're calling for each on the array, but the array takes a callback function, and that callback function is generally anonymous or defined. So whenever you pass something a callback function, passing in either a function reference or a function definition, right? And if you define a function within a callback, this context within those brackets where you're defining the function is the global execution context. So it's not the array. And there's not really a way, I don't think, to bind the for each function to the array, or rather tell for each to bind the there's not a way to tell for each to say, hey, bind, take the callback function and bind its execution context to the array. There may be a way to do that, but I don't immediately know it. But you just have to kind of remember that although for each is being called in the array, the callback function that you're passing or defining in it is not called on the array.
Right, that makes sense. So it doesn't like inherit the for each context. It just, so you can define the function that you call for, that you pass into for each outside of the context of for each.
Exactly. And that's something that, again, we'll continue to see in React, which is why you need to understand when to use an arrow function or when to use the bind. There, you'll find people on the internet that argue bind should always be used, arrow functions are, and I'm kind of just bringing up that, you know, everyone on the internet has an opinion. So the bind is a totally fine way to bind your arrow functions to this context moving forward. Again, you might not understand the necessity of it now, but in the next module you will. And tomorrow and the next day, we'll really kind of go over, I think we're going to take Toytail and we're going to refactor Toytail from a functional style of programming to an OO style of programming. And we'll get everything to work using object-oriented syntax, class syntax. Okay?
Okay, thanks.
Yeah, all right, everybody. Talk to you later. Have a great day. Bye.